Now, in this unit, we are basically going to look at the various types of memory and how they behave. Like I said, today we are going to look at memories and subsystems or memory systems. And all that we're going to be doing this evening is to look at the various types of memory, their characteristics, features, their limitations, and their advantages. So when we talk about a computer memory, what do we mean by a computer memory? We are basically talking about a physical device that is capable of storing data or information temporarily or permanently. That is what we call a memory or a computer memory. It is a device where data is either stored and processed or data is stored for processing. So when we talk about computer memory, we can talk about primary and secondary memories in computer. Now, these secondary memory can also be termed as an auxiliary memory, which is used to store data and programs for long-term storage or until a time when one decides that they do not want to keep it any longer. So when we take a computer, for instance, the memory that is within the computer that stores the various programs or files or the executing files on the computer, that kind of memory can be termed as the primary memory. Please, do we understand?
Yeah.
Now, Danso, I realized you wanted to ask a question. Your hand was raised. If you are here, please go ahead and ask that question. Okay. Now, Konya Ojima, unmute yourself
Sir,
and
please,
ask your question.
Sir, please, that point, can you come again? What you just said, explaining about secondary.
So basically, what I'm saying is that, in short, we can classify computer memory into primary and then secondary memory. Now, when we take a computer, the memory that keeps all the data for execution of programs, the memory that runs the operating system, etc., is what we term as the primary memory. And then when we talk about secondary memory, which can also be termed as auxiliary memory, this kind of memory stores data for long term. So when you take your computer, in most cases, you would have an SSD, but not all the SSDs or the hard drives have operating systems on them. You may have partitioned some of the drive, and that can be termed as a secondary memory, or an external hard drive, which is used to store data for a long period of time, is what we term as a secondary memory. But for that memory which is responsible for any program or file that is currently running or executing on a computer, is what we term as the primary memory. Please, is that clear? Nyako?
Yes, sir.
All right, let's proceed. Now, what are the types of memory? Like we said earlier on, computer memory comes in various types and serves different purposes. So we have the primary memory, which in most cases we call the RAM, or the random access memory. And it is also a volatile memory. When we say something is a volatile memory, what it means is that it loses its content when the machine is turned off. So the RAM we have in our computers, for instance, the Intel I-core RAMs, the RAM that we have in our computers, 8 gig RAM, 4 gig RAM, 16 gig RAM, 32 gig RAM, all these ones are primary memory. But immediately we turn our computers off, whatever is written or read from that RAM vanishes. So we say they are volatile memories. So during the booting process of a system, the operating system actively uses RAM and applications that are necessary to execute a file or a program. It speeds up the CPU processing by providing fast data and instruction access. Yakun, your hand is still up. Do you still have another question? If not, you can lower your hand. Thank you. Then we move on to the other type, which is the secondary memory. Now, the secondary memory is also known as the permanent memory. So whereas the primary memory is a volatile memory, the secondary memory is non-volatile. So secondary memory retains data when the machine shuts down. So the memory within the computer, which stores normal data, which is classified as the secondary memory, even when the computer is off, it doesn't lose its data. So files, programs, and OS are stored there permanently. So example of a secondary memory is the hard disk drive, the solid state drives, the USB flash drives, and the optical disk. These are all non-volatile memory or secondary memory or storage. Then we have another type of memory we call the cache memory. Now, the cache memory is a memory that is smaller and faster than the RAM. And it is placed closer to the CPU than the RAM. And what it does basically is that it saves data and instructions that are used a lot so that processing can be done faster. Kindly give me a second. Another kind or type of memory, another type or kind of memory is the register memory. Now, the register memory, which we can also call the processor register or registers, is the smallest type of computer memory. But this is integrated within the CPU, that is the central processor unit or central processing unit. Now, note that when we talk about registers, they are fast storage and they are small. And what they do is that because they are inside the CPU, they are used to quickly store data that is being processed or any instruction that is being run on the computer. So these are the types of computer memory: the primary memory, the secondary memory, the cache memory, a register memory. Now let's look at the primary memory, or let's take a closer look at the primary memory. We have already established that the primary memory is a volatile memory. As we said earlier on, it loses content when the machine is turned off. Now, within the primary memory, we have two types of memory again. That is the RAM and the ROM. The RAM, which is basically random access memory, and the ROM, which is read-only memory. Now, when we talk about the RAM in a computer, though I have already highlighted this. It stores data that is actively being used. So for instance, during the booting of a process of a system, the operating system actively uses the RAM. Similarly, applications that are necessary to execute a file or a program actively use the RAM. And what this does, or what happens when the RAM is being used, is that it helps to speed up the central processing unit. That is, it provides rapid data and instruction access. And so when we look at the RAM being an example of primary, or a classification of primary memory, we have several types of random access memory. So we have the SRAM, which is the static random access memory. We have the DRAM, which is the dynamic random access memory. Then we have the synchronous dynamic access random access memory. Then we have the DDR, that is the double data rate RAM. So if you have noticed, there are some computers, when you go to buy the computers, the RAM that is installed on the computer, you would see, they would say 2 gig DDR or SDRAM or DRAM. These are all classifications of the random access memory. Then we have the read-only memory. Now, the read-only memory, which is also another classification or type of primary memory, has examples like the PROM, which is the programmable read-only memory, the erasable programmable ROM, the electrically erasable programmable ROM, and the flash ROM. So kindly take note, these are all primary memories. Please, any question? Okay, if there is no question, then we can continue. Now, in this slide, you would see how a RAM looks like. So it is also known as primary or temporary memory. The RAM, like we said, stores data that is actively being used during the execution of a program or instructions. And the RAM helps to speed up the CPU processing by providing fast data and instruction access. So the image you see in here is basically an illustration of how a RAM looks like. So this is a DDR3 RAM. Now RAM, yes, Clement. Clement, kindly unmute yourself and then ask whatever question you have.
Okay, sir, please, what is the difference between the RAM and the ROM?
The difference between the RAM is that for the RAM, it is randomly accessed. But for the ROM, the basic function of the ROM is that the ROM is mostly there is data already written onto the ROM. So it becomes read-only. But the RAM is a randomly accessed memory. Okay? So as we explain the RAM, we would go ahead to explain in details what the ROM is with its features as well. So let's finish with the RAM, and then I would introduce you to the ROM. Okay?
Okay, sir.
All right. Now, to continue talking about RAM, once we start the computer, system files, programs, operating system files are loaded into the RAM. Now, these are normally loaded from a permanent memory into the primary memory for smooth running of the computer. And so the more RAM a computer has, the better it can handle multitasking and the faster it can run applications. So if you have noticed, computers that have bigger RAMs, say 4 gig RAM, 8 gig RAM, 16 gig RAM, they are able to process programs or instructions faster. Do you all agree with me? Or have you experienced that before?
Yes, sir.
Yes, sir.
Okay. Now, a RAM, per its architecture, contains various number of memory locations. And typically, 8 bits of data is stored in each and every one of these locations. And the RAM has the capability of allowing us to read from it or to read from its location and also to write to its location. The biggest disadvantage of the RAM is that even though it is very fast, or it helps the CPU to be able to process faster, it is volatile. It can only be used when the computer is running or when the machine is running. So, since we can write and read from the RAM, there are 2 ways to access data from the RAM. And these 2 ways are the sequential access and the random access. So let's quickly look at what sequential access feature of a RAM is. So when we talk about sequential access, what it means is that data can be accessed from the RAM in a strictly sequential manner or in a strictly orderly manner. So it can only be read from one location to the next location. So assuming there are 4,000 memory locations within a RAM, it has to be accessed in the order of 1, 2, 3, 4, up to the 4,000th location within the RAM. What this means is that it will take minimum time to access location 0, and then it will take more time or maximum time to access location 4000. So for sequential access of RAMs, it disadvantages or it causes the RAM to be slow. So an example where sequential access is used is the magnetic tape, which allows for sequential access of data. So take note of this approach of accessing data. That is the sequential access of data within the RAM. Then the other one is the random access. Now, with the random access technique, what happens is that it can access any of the memory locations in any order. So for example, where we have 4000 memory locations, it can decide to access location 1500, and then the next location is accessing is location 1210. In that fashion, it is not sequential, it is random. And by so doing, it takes almost the same time to access every location within the memory. So random access within the RAM is more preferred. And in a RAM, the access method is random. And hence the reason why we talk about random access memory. Any question before we look at how the random access memory works? Any question? Okay. Since there is no question, let's progress. Now, the RAM consists of something we call who is this person? I don't understand this emoji. What does it mean? Samuel Okoto. Okoto Samuel, I don't understand your emoji. Is it that you are confused or you are blowing me a kiss?
Sir, please, the mistake.
There is no problem, eh? Except
Okay,
I didn't understand your emoji. You are surprised about something?
No, sir.
Or it was just a slip of finger?
Yes, please.
Okay, then let's progress. And so when we talk about how the RAM works, the RAM consists of something we call gate cells. And these gate cells allows the RAM to store data or read data from them. So each and every cell has a unique address. And this is how the CPU requests data from the RAM. And this is done in a very high-speed manner. And this possibility or this feature of gate cells with unique address locations or addresses allows for multitasking or running of complex applications. So Note that the RAM is the computer's internal memory, which stores types of data and information as per the requirements of the computer. And so the RAM is considered a read or write memory. And like we said earlier on, the RAM has a random access technique of accessing data. And since the RAM is a volatile memory, a backup is mostly present in most systems in the form of uninterrupted power supply to ensure that when the machine, for some reason, has to go off immediately, that uninterrupted power supply can provide some duration of power to ensure that processing is halted or is ended properly. Like we said earlier on, the speed and performance of any system is directly proportional to the size of the RAM. So assuming you have an Intel Core i7 processor, I also have an Intel Core i7 processor with a speed of 3.5 gigahertz each. We all have the same thing. If my RAM is 4 gig and your RAM is 2 gig, what is going to happen is that my computer would outperform your computer, or my computer's performance would be better than your computer, assuming all other features are the same, but only the RAM is different. Now, let's look at the characteristics of RAM. The first characteristic is that it is multitasking. It allows for several programs to be executed at the same time and concurrently, or it allows for several instructions to be executed at the same time. Yes, Richard.
Sir, please, my question is like, would there be in a case where like, let's say you're having two computers together and all of them, they have the same features. Would there be in a case where the other one will be faster than the other one?
Yes, there is that possibility. So even though the RAM helps the computer to run or perform very well, it doesn't perform in isolation. It performs alongside the central processing unit, which is the processor. Now, processors differ in architecture and design. So, for instance, I use an Intel Ultra 7 processor, which is faster than the normal i7. So your computer, which is a normal Intel Core i7, could have 16 gig RAM, and my computer, which has the Ultra 7 processor with 16 gig RAM, mine will be faster than yours, because even though the RAM sizes are the same, the processors are not the same. Please, do you get it?
Sir. Yes, sir.
Now, another thing that can cause the difference in performance is the generation of the processor. We have evolved several generations. That is why even for the i7, currently we have the Ultra 7 or the Ultra i7 processors. We have the 6th generation, the 7th generation, the 8th generation, 9th, the 10th. These are all factors that can affect the performance of the computer. But granted that all these parameters are the same, then we can check the performance based on the size of the RAM. Please, is that clear?
Yes, sir.
Okay, let's progress. So the characteristics of RAM. The first one is multitasking. It allows for execution of instructions and programs to be done multiple times, or different programs or instructions running at the same time. Now, it also prevents system crashes. What the RAM does is that in an event where there is the possibility of a system crash, it triggers something that allows the system to slow down. So I don't know if you have ever witnessed, you have several processes running, and then at the point you see that the computer has hanged, you are not able to perform any other function. It is the RAM's own way of protecting the system from crashing. So that is one feature of the RAM, or one characteristic of the RAM. The other characteristic is that it has high performance. So where you have RAMs that are of bigger sizes, you are able to do a lot of, or perform a lot of activities, or execute a lot of programs with performance. So look for those of you who probably love games, or those of you who watch movies in high definition, or have softwares that render with very good resolutions, you will see that the RAM in such systems that are able to give you such resolution as well as high performance gaming is very big. And then it has a system support feature on its own because of its capability of allowing us to perform a write or erase operation. And because it is closer to the CPU, it facilitates faster data accessing or assessment. So you can access data faster. In terms of cost, if we are comparing the RAM to the solid state drive, then we can say that the RAM is not costly, or it is cheap. So that is, or these are the characteristics of the RAM. Now, like we looked at earlier on, we said that the types of random access memory we have the static and the dynamic random access memory. So if you look at this diagram here, this is to illustrate and tell us the various types of static random access memories we have and the various types of dynamic random access memories we have. So for the SRAM, we have the synchronous, asynchronous, pseudo-synchronous, non-volatile synchronous RAM, the SDRAM for the dynamic. Then we have the DDR SDRAM. Then we have the DDR2 SDRAM. We have the GDDR, the LPDDR, the RDRAM, and the EDO RAM. So we're going to look at these one after the other. Now, the SRAM, which is termed as the static random access memory, is a type of RAM that uses something we call flip-flops. So as part of your reading assignments, I would want you to go and read on flip-flops. It's a semiconductor device which you would be studying in details in semester 2 in digital electronics. Now, flip-flops have a certain feature that allows for latching or holding onto, okay? This SRAM is also a volatile RAM. It is a semiconductor RAM. And it stores data using, or it stores bits in the form of data using bistable latching circuitry, which allows it to be very fast compared to, or like, the cache memory, which we'll look at very soon. But in our introduction, you remember we said the cache memory is the fastest memory because of how close it is to the CPU. Now, the SRAM is commonly used as the central processing unit's cache, and it is normally located in level 2 or level 300. So when we get to cache memory, you would see that the cache memory has several levels, and these levels determine how fast they are. And what happens is that for the SRAM, which is the static random access memory, it stores data in the latch if the computer is on. Because of its volatile nature, when the computer is off, it cannot store data. Now, the static RAM is more expensive and requires more power than the dynamic RAM. And like we said earlier on, it serves as cache memory in a computer. Now, all these memories, because they are semiconductor devices, their design is made up of transistors. So the SRAM would require more transistors than the dynamic RAM. It is also faster than the dynamic RAM because of that flip-flop in its design, which gives it that latching capability, the holding on capability. And so for every data bit, the SRAM would need 6 transistors for its design, while the DRAM or the dynamic RAM will use just 1 transistor per bit. Now let's look at the characteristics of the RAM, or the SRAM, even though we have mentioned a few of them. It consists of memory cells, or it has memory cells which consist of 6 transistors. It contains flip-flops that are used to store data units. The SRAM is dedicatedly designed for the CPU, and it works as a cache memory. It is faster than the DRAM, and it takes less time to access data. One thing that needs to be done when there is a need to store large amount of data is that one single chip cannot be used. So there will be the need for several chips. And this makes the SRAM expensive. And in order to store data, it requires more supply power, or it requires supply power to store data. And because of this, it generates more heat. The contents of the SRAM would always be as it is until it is turned on. So these are the features of the SRAM. And like we said, the types of SRAM, we have the synchronous SRAM, which would work closely or jointly with the clock signal. So it works in sync with the clock signal. That is, it reads and writes in a synchronous fashion with the clock signal, making it faster and suitable for high-speed applications. Then we have the asynchronous SRAM. This is not dependent on the clock signal. Once the address and control signals are stable, it can read and write, or it can be read or written into. So whereas the synchronous static RAM works jointly with the clock signal, the asynchronous SRAM only needs the address and control signals to be stable, and it'll work perfectly. Then we have the pseudo SRAM. It has both the features of the dynamic RAM and the static RAM. So what it does is that it uses the RAM or the DRAM cells, but includes an internal circuitry or refresh circuitry. And then the SRAM now becomes an external system to it. Then we also have the non-volatile SRAM, which has a very small non-volatile memory with the SRAM cells to keep data even when the power is off. But originally, we know that SRAMs are volatile. But the type of SRAM that allows to keep some small data when power is off is what we term as the non-volatile SRAM. Yes, Joseph. Joseph, your hand is up.
Sir, please take the pseudo SRAM for me. I couldn't get it clear.
So basically, what we are saying is that the pseudo SRAM, what we are saying basically is that the pseudo SRAM is a type of memory that combines the features of a dynamic RAM and a static RAM. Okay?
Yes, sir.
So the pseudo SRAM has a certain feature of the dynamic RAM and the static RAM. And it uses a dynamic RAM cell and also uses the SRAM itself. Do you understand?
Yes, sir.
All right. Now, advantages of the SRAM. SRAM is preferred because it is much faster. It does not require being refreshed. It delivers faster read and write operations. And one of the reasons why the SRAM delivers faster read and write operations is that it works as a cache memory within the CPU. And one advantage again is that it is less prone to errors and data corruption that is caused by the refresh process, because it does not require being refreshed to be able to perform properly. And because of its reliability, it is used as cache memory. So these are the advantages of the SRAM. Now let's look at some of the disadvantages of the SRAM. It is expensive. And because of its complex structure, its design and layout are more complex. Again, because of its volatile nature, data that is written or read from the RAM is lost when there is no power or when the power goes off. Now, comparing the SRAM and the DRAM, the SRAM has lower storage capacity. Again, because of its complex structure, it is very difficult to build or to understand its design. And so, it is not allowed for large memory applications, or it is not used for large memory applications. So in all, we can say that the speed and reliability of SRAMs make them very expensive, and particularly for applications such as CPU caches. However, its high cost and low density compared to DRAM restricts its use to smaller, high-performance memory applications. So these are the disadvantages of the SRAM. Any questions? Okay. Now, let's look at the dynamic random access memory. The dynamic random access memory. It is another type of RAM used as main memory. And what it does is that it stores data in capacitors for a short period of time. I mean, a few milliseconds, even when the computer is powered on. So with this type of RAM, each memory cell within the RAM contains 1 bit of data, and it is composed of transistors and capacitors. That is the DRAM chip. Now, the data that is written and read in this type of memory is constantly updating because of the memory controller. And whereas we have in the static RAM that it does not require refreshing, the DRAM data is refreshed regularly to ensure that the data is of good integrity, in order not to compromise the integrity of the data. The DRAM is considered to be less expensive. However, it can store significant amount of data. And it is slower and requires less power than the SRAM. So the DRAM can store more data. It is not fast compared to the SRAM, and it does not require more power than the SRAM or compared to the SRAM. And so these features make the DRAM less expensive than the SRAM. And it is suitable for a lot of CPU memory applications. And when it comes to the architectural design, the DRAM is slower than the SRAM. And if it has to be linked to the CPU, it can be linked directly to the CPU bus. And in most cases, you would find DRAMs in the ranges of 4 gigabytes to 16 gigabytes for laptops. And then for smaller devices, you may find 1 gigabyte to 2 gigabytes for smaller devices. So, to pin out or to state categorically what the characteristics of the DRAM is, it has the capability of working as a main memory for the system. And it has capacitors that store data. And so there is the need to refresh multiple times. It is inexpensive, so you would find them in most laptops or personal computers today. It also requires less space and less power. And because of the refreshes, this helps to maintain data consistency. And it is power efficient compared to the SRAM. And it can also store multiple bits on a single chip, whereas the SRAM would need multiple chips. Now, similarly, for the DRAM, we have the synchronous DRAM. Yes, Joseph.
So I want to verify whether the DRAM is also volatile. And when we are talking about the performance, are you saying like after you refresh it, you still get the intent of the message after it went off?
Yes. So it is also volatile. But the point here is that its volatility also depends on the refreshing of the memory, because there are capacitors which are capable of storing data. Even though it can be volatile, these capacitors are able to store some data. So during the time of refreshing, you don't lose the data, but it keeps the integrity of the data.
Thank you, sir.
All right. Just 1 second. So the types of DRAM, we have the synchronous DRAM. And when we say something is synchronous, what it basically means is that it syncs with a certain time. Okay, so in this case, it is synchronous with the bus clock. Then we have the DDR SDRAM. It has higher data transfer rates compared to the SDRAM. Then we have the DDR2 SDRAM, which has higher speed, lower consumption, and enhanced latency. Then we have the GDDR, which is optimized for graphic processing units. Then we have the LPDDR, which is mostly used in mobile and embedded systems. And then we have the RDRAM, which is for innovative designs that require very high performance capabilities. Then we also have the EDORAM, which allows for faster read cycle by performing overlapping operations. So these are the types of the dynamic random access memory. Now let's look at the advantages of the dynamic random access memory. It has a slower accessing time compared to the SRAM. Yes, Edwin.
Okay, so say the type of the dynamic RAM. Yeah, the first point was the SRAM, and I wanted to know, isn't that the synchronous random access memory?
It's SDRAM, synchronous dynamic random access memory. We are not talking about
Okay, sir.
synchronous random access memory here. We are talking about dynamic random memory. The first one where you have SRAM, we are talking about static RAMs. And we talked about the fact that the static RAM has several examples which we looked at. Now we are looking at the dynamic RAM and its types. So the first one is the synchronous dynamic random access memory. Is that okay, Edwin?
Yes, please.
Okay. So the advantages of the DRAM, it has a slower accessing time than the SRAM, and its design is simple, not complex compared to the SRAM. It is also smaller in size. And compared to the SRAM, it is less costly. And because it has rates, there is a possibility of high congestion rate. Just 1 second.
Right.
Yes, please go ahead. Someone wanted to say something. Yes, Joseph.
Um, if you can enlighten on the high congestion rates.
So when we talk about something is congested, you see how most of the time, because of your numbers, you have, because the room, even though the room is big, the numbers are so much. And so everybody is entering into the room and it doesn't allow movement to be very fast. So there is most of the time congestion. But if movement were supposed to be fast, when you finish class and you need to leave the room, it will be very easy to move out. So the congestion is very high compared to that of the SRAM. Or if you're looking for another word for congestion, there is crowdiness, or the place is crowded, or crowding rates are high. Okay, Joseph?
Yes, sir. But we said the advantage, and this point I don't know. Okay, but thank you.
So what it basically translates to is that because of the large memory space, you are able to keep a lot of data in there. Or you are able to force a lot of data into that memory. It sounds like a disadvantage, but it's an advantage because
Okay,
of the
sir.
large memory space. Okay. Then it has a high density that makes it suitable for large memory applications. So the disadvantage is that it is volatile. And that is the reason why we would continue refreshing it to keep data consistency. Even though its manufacturing process is complex, which is a disadvantage, when you compare it to that of the SRAM is more complex. However, it is also complex to manufacture. It is slower than the SRAM, and it has high latency compared to the SRAM. So kindly take note of that. Now, we move on to look at what a ROM is. What a ROM is. Now, a ROM is basically read-only memory. And it is a non-volatile, yes, Joseph, your hand is still up.
Yes, sir. I want to verify something from the previous one that we had, the RAM.
Okay.
So you first of all, you were saying that the RAM, it uses transistors, and the point when you came to the DRAM, you said it uses capacitors.
Yes.
I don't know if I'm getting it or yeah. So you mean
it uses transistors and capacitors.
okay.
Go ahead with
Thank
your
you,
question.
sir. That's what I just want to verify.
Okay. All right. Now, so the ROM is a non-volatile memory that is used to store data permanently. So in some applications, like for instance, when you take a printer, for instance, you realize that the printer, when you start it, it has some software on it that will normally help to start the printer. Have you noticed that? There is normally a memory that is installed in there. So a ROM is a non-volatile memory that stores data permanently. However, advanced ROM data can be erased and rewritten. So even though it stores data permanently, it means that we can erase the data in there, and we can also rewrite into that memory. So in this case, it makes a perfect use in computers, and this allows for quick access to data without having to rewrite the data every now and then. So for instance, important data like BIOS settings, operating system instructions, etc. are stored in these memories, which are crucial for proper functioning of the computer. So, in other words, we would say your computer is a brain-dead machine if they don't have a ROM. They need the ROM to work effectively, or they will need the ROM to function properly at all times. Now, the ROM is an efficient storage method that needs minimum effort in maintaining it. And it is capable of holding different types of data. So the ROM would normally have multiple inputs and multiple outputs. So within the ROM, you would have several data being stored within the ROM. Characteristics of the ROM. It has several memory locations, which is typically 8 bits. One thing I would want you to go and look out for is that when we talk about 8 bits, what does it mean in terms of words? So try and get the understanding of 8 bits and the conversion to word. When we talk about 8 bits, how many words does that mean? Now, the ROM also uses the method of random access, just like the RAM. So if you remember, when we're looking at the RAM, we said that there are 2 types of data access. we talked about the sequential data access and then the random data access. And we said the random data access makes the memory faster. So similarly, as a feature or characteristic of the read-only memory, it uses the random access method of data assessment or assessing of data. One advantage of the ROM is that it is non-volatile in nature. So when power to the ROM is even switched off, the information on the ROM would not be lost. It will still be intact. Even though we explained earlier on that advanced ROMs can be erased and new data written into, ROMs are only allows reading from a location within the ROM. So for most of its operation, ROMs are intended to be read from. And so even though the computers will be off, the data that is stored within or on the ROM is never lost. Now, how does the read-only memory work? Here, it is also composed of transistors that are arranged in series. And in this case, it allows current to flow when powered. And you know that wherever there is current, there is magnetic field. You would all agree with me on that.
Yes, sir.
And so the magnetic field helps to retain the data within the memory cell until it is erased by another signal through the transistor. And so within the ROM, whatever information has been stored in the cell cannot be altered or deleted unless this is done by an external entity like the computer processor or the hard drive controller. And so within the computer, there is a small durable battery that powers the ROM. And it has some components or two components that are very essential for its operation. And these are the decoder and the OR logic gates. So you take note of this. This may sound a little bit confusing because you haven't studied digital electronics yet. And since I don't want to go into digital electronics for this course, we can do that another time so you can understand the logic gates proper. what I'll urge you do is that, I don't know if it is your class, but I remember sharing some books, some textbook to my students, Taraja. In one of those sessions, or in one of the, yes, in one of the sections, you would find logic gates. Take your time and then read on them, and it will further enhance your understanding of how logic gates work. So the decimal output of the decoder is used as the input for the OR gate in the ROM. And so the ROM is akin to an array of disks. And the system can be activated and deactivated using a grid of rows and columns. I won't spend so much time here, as this will look more abstract for you because of the digital electronics in there. Now, let's look at an example of the ROM, which is the max or max programmed ROM. It is termed the max programmed ROM because during the time of manufacture, this type of ROM has a mask. And so once information is written, it cannot be changed, even by the manufacturer. And so it is cheaper compared to other types of ROMs when considering cost per unit quantity. It is also used in equipment that are produced in large quantities. So mostly in network operating systems. For instance, in systems where you would have switches, access points, or systems where you have server operating systems, this kind of ROMs are mostly used. Then we have the programmable read-only memory, that is the PROM, which is also a type of ROM. Now, in this type of ROM, there is something we call the PROM programmer. That is the programmable read-only ROM programmer, which is used to write information onto the ROM. And once information is written on this kind of ROM, it cannot be changed. So compared to the mass program ROM, the programmable read-only memory is also permanent, or information written on it is permanent. However, when it comes to cost, that one is more expensive compared to the MP-ROM. And you would find its application in TV remotes, video game consoles, and in some applications today, you would find them in mobile phones. Then we have the erasable programmable read-only memory. That is the EEPROM. It also uses the EEPROM programmer to write information onto the EEPROM. However, for the EEPROM, its content is erasable and rewritable. So it means that whoever is using this kind of ROM can modify its contents multiple times. And the method of doing this is by the use of a UV light. And it is mostly used in video cards, memory sticks, BIOS chips, and modems. Then we have the EEPROM, that is the electrically erasable programmable read-only memory. Yes, Abdul Hamid Usman.
Okay, so I wanted to ask, was it really necessary for them creating the a programmable read-only RAM as to where, and then later they brought up the erasable programmable read-only RAM? Or is it with the generations that we first produced the programmable read-only RAM, then later we knew that we can also bring another one up that will also be erasable?
Yes, so you see, when you look at the applications for which these ROMs are used, you realize that for the programmable read-only ROMs, for instance, a TV remote, when you buy a TV remote, whatever program has been written on the ROM, also note that this ROM is non-volatile. So the information on the ROM is permanently written there. However, you would never go to change the program on a remote controller because you don't need to change it for anything. The program on a video game console, you may only update the games on the console, but the program that is written within the console, you are not going to change it. So that is an application. Now, when you come to something like memory sticks or video cards, from time to time, there would probably be the need to change the data that is written on these cards. And so there was that provision within the erasable programmable read-only memory so that in instances where we would need to do some changes, we can erase and rewrite onto them. Please, do you understand?
Yes, sir, I do.
Okay. I don't know if I have been able to answer your question.
Yes, sir, it's good. It's really good.
Okay. So we got to the electrically erasable programmable read-only memory. That is the EEPROM. Now, in the EEPROM, the information is written by using the EEPROM programmer. Now, the electrically erasable programmable memory, data is rather erased using electrical signals compared to UV light being used to erase data on the erasable, programmable, read-only memory. Now, for the electrically erasable, programmable, read-only memory, there is the possibility of selective data erasure, which means that some data within the memory can be erased, leaving some data on the memory. And this makes it more expensive compared to the other types of ROM. And because of that feature of selective data erasure, this leads to some flexibility in usage. And so you would find this used in microcontrollers and microprocessors. So for instance, when you take the Arduinos, you would find EEPROMs in the Arduino as the means of data storage. So when you start using Arduinos and you pay attention, you would see that the data that is being stored on the Arduino using the programmer is basically the EEROM that allows for that data storage. Am I speaking too big English?
No, sir. Yes, sir.
Someone
Yes,
said
sir.
broth. Someone
Yes,
said
sir.
brothful.
Bro, I know what then.
Sorry about that, but it's because of the technical terms. That is why.
Yeah, it's okay. At least we are learning some English.
All right, Hanson.
Sir, please, I wanted to ask how would the SRAM questions will be, or how will you set it?
Oh, Brad, my mention at the area. Hanson, we are not done yet. We are left with about 12 slides. So I'll finish very soon.
Hey.
Okay, sir.
Upon them.
Hey.
I support you because some of us,
Don't worry, you write your midsem. Don't worry. Let's learn first.
Yeah, take us to have fun. This traffic more. A driver who feels no. Yeah,
It is well. All right. We'll finish very soon. The remaining slides are not so intensive.
Okay, sir.
All right. Now, let's look at a comparative analysis of the various read-only memory based on type, who enters information or who can write on these, and then if there is a possibility to erase them, cost features, how they are purchased, the method of erasing, and their application. So you would see that the MP-ROM, it is only the manufacturer who is able to write on them. There is no possibility to change. It's cheap, so can be ordered in large quantities. There is no way to erase information. and this can be produced in large scale. Then we have the PROM. It is the user who writes on them. There is no possibility to change anything. They are expensive, and so mostly when ordering them, one may not be able to order a lot of them. And there is no possibility of erasing information written on them. And they are mostly medium scale produced. Then when it comes to the EPROM and the EEPROM, it is the user that writes onto them. The user has the possibility of changing whatever has been written on them. And then also, they are more expensive. Now, when you take the EPROM, you can erase, but by the usage of UV light, strong UV light. And then the EEPROM can be done using electrical signals. And for the EEPROM, there is selective erasure of data. And these are produced for research and development. So now let's move on to look at secondary memory. So all that we have been doing is primary memory. We will quickly look at secondary memory and then bring today's class to an end. So when we talk about the secondary memory, the secondary memories normally store data and programs permanently, even when the computer is off. And we term these as the external or auxiliary memory. So we can classify the secondary memory into magnetic storage, optical storage, flash storage, that is solid state storage. We can also have cloud storage, where you have Dropbox, Google Cloud. Today you have Google One. We have OneDrive. You can name them. iCloud. These are all examples of cloud storage. Then we have hybrid storage. So when we take the secondary memory, for instance, for the magnetic storage, we have the normal hard disk drive. Then we have the floppy disk, which is very obsolete now. You would not find any computer that uses the floppy disk drive. I was privileged to see a computer that uses the floppy disk drive, even though I'm very young. And then there is the magnetic tape. And then we have the optical storage, where we have the compact disc. Now, if you have paid attention, you would notice that when it comes to CDs or compact discs, we have CD-ROM, which is read-only. We have the CDR, which is recordable, and then we have the CD-RW, which is rewritable. So some few years back, when you want to get music, you burn music onto a CD, you go and buy the CD recordable. And then you go and record a lot of music on it. And then you put it in your CD player. Those times we call them the CD Walkman. You'll be carrying them around and be listening to music. Then we have the DVD, which is the digital versatile disc. Similarly for that one as well, we have the DVD-ROM, the DVD read, and then the DVD read plus. Then we have the DVD write, and then the write plus. Then we have the Blu-ray disc. And then for the flash storage, we have the solid state drive, which is very common today because of its features. And then also, we have the USB flash drive, and then we have the micro SD, as well as the SD, which forms part of memory cards. Then when you come to the cloud storage, like I said earlier on, we have Google Drive, Dropbox, OneDrive, Amazon, iCloud. These are all examples. Then we have hybrid storage. Hybrid storage, for some computers today, you would find hard disk plus an SSD. And then for some of them, you have solid state hybrid drive. These are all examples of what, or types of secondary memory. Now, let's look at what we term as the cache memory. If you recall in our introduction, we said that the cache memory is the smaller and faster RAM or memory, but smaller and faster than the RAM. And the image here illustrates how the cache memory looks like. And if you remember, we also said that the cache memory is closer to the CPU than the RAM. And based on the levels, L1, L2, and L3, the cache memory has different speeds and amounts of space for storage. And so this level you see, which is level 1, 2, and 3, is according to the speed and the size of the cache. So let's look at level 1 cache. The level 1 cache is the fastest, or it is the computer's fastest memory. And so most of the data that will be used frequently within the computer resides at level 1. So there is a graphical illustration of how a cache memory looks like and how it is connected to other parts of the computer. However, it is the CPU that determines the size of the cache. So the Intel i9 and the IBM, the Intel i9 has a 1 megabyte level 1 cache, but they are very rare. It's not common to find them. Then another chipset like the Intel Xenon has 1 to 2 megabytes L1 memory. So it is advisable that before you buy, you examine the CPU specifications and then ascertain the L cache before you buy them. Normally, when you get to know the processor, you would have an idea of what the size of the L cache is. Now, the level 1 cache normally has 2 sections. That is the instruction section, which stores CPU information, and then the data section. So you'd find L1D and then L1I. So you take note of that. Then we have the L2. This is larger but slower. So the size is bigger compared to the L1. They are mostly in gigabytes. So AMD top rated Ryzen 5, 5600X has 384 kilobytes L1, and then 3 megabytes L2 and 32 megabytes L3 cache. And like we said, most of the time, the L2 cache size would depend on the CPU, but it will usually be within the ranges of 256 kilobytes to 32 megabytes. Now, in terms of speed, as established, the L2 cache is slower than the L1 cache, but it is still faster than the system RAM because the cache is closer to the CPU. The L2 cache are 25 times faster than the RAM, while the L1 cache are 100 times faster than the RAM. Now let's look at the L3 cache memory. Now these are originally on the motherboard. And this was way before when we had CPUs a single core. Now the L3 cache has a bigger space or capacity. It can reach 32 megabytes. So for example, the recent Ryzen processor, which is AMD's processor, that is Ryzen 7, has a CPU, or its CPU has an L3 cache of 96 megabytes. And in some server applications, you can find the cache memory reaching 128 megabytes. Now, the L3 cache is the slowest, but the largest. So you take note of that. So this slide here gives a comparison between the 2012 Intel Core i5 3570K CPU and then the 2020 AMD Ryzen 5800X. Now you will see that for the Intel, you have the various sizes. L1D cache is 32 kilobytes. L1I cache, that is data, is also 32 kilobytes. L2 is 256 kilobytes, and then L3 is 6 megabytes. So this confirms that the L3 has the largest space, but it is slower. Now let's look at that of the Ryzen. So L1 has 8 times 32 kilobytes. L2 has 512 kilobytes times 8. And then the L3 has 32 megabytes, 16 way. So you would realize how big the L3 cache is, but slower in speed. So now, how does the cache memory work? Most computers have L1, L2, and L3 caches. And these are several layers in the memory. And like we have said earlier on, the L1 is the smallest and fastest, and located very close to the CPU. Yes, I have some hands up.
Please, the calculation there you just did, it seems the words was too small, so you couldn't see some of the words over there. The
Yes,
numbers that you're talking about.
the image wasn't very clear, but
yeah.
When you look into the slides, you would possibly see it clearly. Or when I share the video to you, you can try to zoom it and see.
Okay, sir.
Let me see something. You mean this, right?
Yes, sir.
I'm trying to enlarge it, but when I do, it pixelates. So you will see from here, because it was a screenshot taken from somewhere, it's not too clear.
Okay,
but
sir.
basically, what we're trying to put across is that for the L1 cache, that one is the fastest and closest to the CPU. The L2 is not as fast as the L1, but it's faster than the L3 and has more space than the L1. Then the L3 has more space, but not as fast as the L2 and then the L1. Okay, so the cache memory, they work in hierarchies. That is why we have level 1 and 2 and 3. Now, there is also cache organization. Each block or line of cache memory contains a small bit of data, which is copied from the main memory. There is also cache coherency. What this means is that they ensure that the data that is within the cache matches the main memory data. Then we have the cache replacement policy. So that when the cache is full, it decides which block to evict. So we have random replacement. That is first in, first out. Then we have cache access, where the CPU checks the cache before reading or writing data into it. Then we have the cache hierarchy. So that there could be parallel access. Then there is cache management as well, to ensure optimization of cache and then maximum utilization to hit the maximum rates. Now, there is also the usage of, yes, David. David, your hand is up. Patrick. Patrick. Okay, so there is also the usage of something we call memory buffers, which are used to access data between the CPU and the main memory. And what this does is that it speeds up processing and increase system performance. And to ensure efficiency, there is always the need for effective management within the cache to ensure efficiency. Yes, please go ahead and ask your question.
Yeah, I wanted to enable the microphone, but my phone was misbehaving. That's why I wanted to ask about the buffer. So we are just recently
You wanted to ask
that
about what?
The buffer.
Okay. What about the buffer?
So that the buffer is used to store like some data at a short time, so that it can correct a mistake or those things when during the process of transfer and those things. So I wanted to ask, where do we put it in the type of memory as it's stored to? And now I'm seeing you are taking up onto it, the buffer.
I don't understand. Isn't that you are saying you had wanted to ask me a question about the buffer, but I have explained it?
Yeah, you are starting now explaining it. So that's why I will listen. If I don't understand, I will come back.
Oh, okay. So basically, what we are saying is that even though we have the memory, the main memory, and then we have the cache memory, to ensure that we increase performance during processing, the buffer is placed between the memory and then the main memory and then the CPU for movement of data so that we don't lose the data. Do you understand? So it holds the data during the movement of data between the CPU and the main memory.
Okay, sir.
Yes.
Yeah, but the data, the way it worded, say it's worded before the transfer or during the transfer or after the transfer.
During the transfer.
So that means it's used like a L1 to be quicker or L2.
Come again.
That means that it use the L1 cache or L2 to be quicker as is storing the data at the same time of the transferring.
I'm not getting what you're trying to ask. Are you asking
Ask. Is use any of the L cache memory? That's my question.
Because
use L.
So because we need faster processing, the buffer sits between the CPU and then the main memory. The cache is very close to the CPU for processing. So when the processor is getting data from the main memory, it is the buffer that holds the data throughout the process of transferring the data from the main memory to the CPU, and then from the CPU to the main memory. Do you get it?
Oh, okay. Yeah, I get it. But L1 or L2?
L2 and L1 are basically cache memories. They are used for processing of information faster. However, because you would need to process the data, L1 is more faster than the remaining two. So depending on what application, the computer will decide which one to use, whether to use the L1 cache or to use the L2 or the L3 cache.
Okay. Okay, now I understand. Thank you,
Billy
sir.
B. David Ninto. David. Okay, so now let's look at the last thing, which is the register memory. Now, whereas the cache memory is closest to the CPU, the register memory is also the smallest and fastest type of computer memory that is integrated directly into the CPU. They are small but fast storage units inside the CPU that are used to quickly store data that is being processed or instructions that are being run. So if you remember when we looked at the connection between the processor and the main memory, you will realize that there were some registers within the processor. That is the function of those registers. Registers serve several important functions, one of which is instruction execution, data storage, and addressing. So these are the main functions of the register memory. And some types of register memory, as we looked at in our earlier lectures, is the program counter, the instruction register, the memory address register, the memory data register, and the general purpose registers. And we said that the program counter stores memory address of the next instruction to be executed or fetched and executed. And then the instruction register holds the current instruction being executed by the CPU. And then the memory address register stores the memory address of data being read into or written to the memory. And then we have the memory data register, which contains the actual data that is being read from or written into the memory. And then we have the general purpose registers, which are used for general data storage. So this brings us to the end of the memory systems. I hope this has been informative for you and you have learned one or two things. So in our next class, we would look at input and output processing. Yes. David is not speaking.
Yes.
Osman.
So I was trying to ask, can the register be edited? Because sometimes you may be looking through your computer and you find the reg edit. So is it the register that has been integrated directly on the processor? Can it be edited?
So normally the reason why you would edit a register on a computer is because probably you have done some installation and that has been stored in a certain register. So because you would want to reinstall something else without the computer remembering that there was a previous one, that is when you go to edit the register within the system to do that. Yes. So you can do editing of registry content, but not the register itself. It is the content of the register that is being edited.
All right, sir.
Please, is that clear?
Yes, sir.
Okay. Patrick.
Yes, when we were studying about the code, the instruction process, there were things that we call accumulator, and you said that it store some data. What type of storage is that?
When we were looking at the instruction registers, when we're looking at the instruction execution, you mean?
Yes.
I remember one instruction where there was a register, and we said that the register is a memory that is used to store the information that has been executed or is being executed. Is that not it?
Yes.
So what exactly do you want to understand here?
So I hear the word accumulator too in it.
What?
Accumulator.
Accumulator.
Yeah.
In which class? In this class?
I think so. I hear accumulator on instruction execution.
Okay.
And I did some research about it. They say that it's like a storage that we can, during the execution of an instruction, we can store some data in it. So
you mean
do addition
accumulators?
Yes.
Okay. Yes. They can also be used to store information during the execution of instructions. Yes.
Okay. Also, the main code, the main instruction that is stored in the storage, and we talk about the interruption there. When the program gets interrupted and is running the interruption program, where this program is stored on where the address instruction is, or it has a other location to store the interruption instruction.
I'm finding it difficult to hear what you are asking.
I said that the interruption routine.
What routine?
Is the interruption routine service, ISA.
Okay.
Yeah, it's instruction that you contain. Yeah, where does this instruction is stored in the processor?
If mostly all instructions are stored within the main memory, they are only brought into the processor for execution. So until they are being executed, they are not in the processor, they are in the memory. So it is only when they are being processed that they are brought into the processor and kept in a certain register. But in this case, the program counter is the one responsible for fetching the next instruction from the memory into the processor for execution. So the interrupt service, the ISR, is also an instruction that is within the main memory, but it is being executed within the processor. So during the time of execution, it would have been fetched from the main memory into the processor. Please, do you understand?
Yes, sir.
Okay. Any other question? Okay, so in the absence, yes, Hansen.
No
Hansen,
question.
your hand is up. Okay. All right, so in the absence of further questions, I think we would bring today's class to an end. And then our next unit is going to be Unit 5, which would be input processing, input and output processing. And then when we are done with that, because of especially the diploma guys, and for you HND students not having any knowledge in programming, but only going to be doing MATLAB programming in year 3 for HND, we would look at C programming, introduction to C programming before exams. That will be after Unit 5. So right after mid-semester, the first week after mid-semester, we are going to finish the input and output processing. And then the remaining 3 weeks before exams, we shall quickly finish with introduction to C programming before you start your final exams. And that will mean that we would have covered everything in the course outline. So I see a hand up. Feel free to ask your question.
Okay. Sir, please, we haven't received most of the slides.
Are you saying you haven't received the slides?
Yes, please.
Are you sure? Because I have shared every slide on your
Yes,
platform.